Hello. Hello and welcome. We're back for Advent of Code Day 9, series in which I work on every day's challenge in Advent of Code until I'm not enjoying it anymore, and I'm currently still enjoying it. Day 9, Movie Theater. You slide down the fire pole in the corner of the playground and land in the North Pole-based movie theater. The movie theater has a big tile floor with an interesting pattern. Elves here are redecorating the theater by switching out some of the square tiles in the big grid they form. Some of the tiles are red. The elves would like to find the largest rectangle that uses red tiles for two of its opposite corners. They even have a list of where the red tiles are located in the grid. Your puzzle input. Showing red tiles as blah blah, it would look like this. You can choose any two red tiles as the opposite corners of your rectangle. Your goal is to find the largest rectangle possible. For example, you can make a rectangle shown as 0, or shown as O's with an area of 24 between 2, 5, and 9, 7. Or you can make blah, 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 blah. What's the largest rectangle you can make? Okay. Alright, so part 1 should be easy. I'm sure part 2 is going to be fucked up, though. For line in F. Red dot append. Tuple of int x for x in line dot strip. Dot split on a comma. Okay, so now I've got my corner tiles. I don't think there's a particularly clever way to solve this one. I assume... So one approach you can take is just by mapping the tiles to like the Pareto optimal envelope. So essentially like you keep a running max as you go from left to right, and every time you find a tile that updates your max, you keep track of that one in particular. And then you just start from the right end, I think. I've got like a picture in my head of how to narrow this search space down considerably, but I don't think I need to do any of that. So I'm not going to, but the second half may force my hand, so we'll start with something simple. So for I comma cxcy, no, axay in enumerate red. For bx by in red starting at I plus 1. I'm just going to try, best I've seen is 0 so far. Size is absolute value of ax minus bx plus 1 times... Is it math absolute in Python? I can never remember. No, I think it's a global function. Yeah, okay. I'm just rushing down part 2 because I'm curious how they're going to make this harder. The elves just remembered they can only switch out tiles that are red or green, so your rectangle can only include red or green tiles. In your list, every red tile is connected to the red tile before and after it by a straight line of green tiles. The list wraps so the first red tile is also connected to the last red tile. Tiles that are adjacent in your list will always be on either the same row or the same column. Using the same example as before, the tiles marked X would be green. In addition, all of the tiles inside this loop of red and green tiles are also green. So in this example, these are the green tiles. The remaining tiles are never red nor green. The rectangle you choose must still have red tiles in opposite corners. Red tiles in opposite corners, but any other tiles it includes must now be red or green. Oh, I don't like this. So I essentially just need to form the polygon. How many corners are there? 500? This is just like an annoying geometry problem. I think there might be an easy solution to this. Hold on. In order to not be valid, oh God. So you still have to make sure that the rectangle you're forming is internal to the polygon that's being created here. But one thought I'm having is that if you want to know whether or not this forms a valid rectangle... No, I can think of a counterexample. It's not enough. Fuck, that's hard. That's annoying. Using two rectangles as opposite corners, what's the largest area of any rectangle you can make using only red and green tiles? Figuring out which set of tiles is internal is already hard enough, though. I guess you could just do a flood fill algorithm, but I'm a little concerned about that, actually. I know a few geometry algorithms that could help me here, but I'm trying to like figure out what approach I want to take at this. There's a few geometric algorithms you can use to determine whether or not a point is inside of a polygon, though most of the algorithms I'm thinking of require convex polygons, and this one's not guaranteed to be a convex polygon. In fact, the examples are non-convex. So I don't think that works. But there's still approaches you can take. I'm worried that my only option is going to be a flood fill algorithm. And I don't really love the idea of doing a flood fill algorithm when I can't determine internality of the polygon. I'm not confident that I can do this effectively. Are there some algorithms I'm not thinking of? Like, is there... point in polygon test non-convex. Okay, there's the ray casting algorithm I'm familiar with. I know this one a little bit. I think that would work for me. The winding number algorithm. This is what I was trying to remember. This does not seem to give a shit about convex polygons. I thought the winding number algorithm only worked for convex polygons. One way to compute the winding number is to sum up the angles subtended by each side of the polygon. Okay, I think I'm going to do the ray casting algorithm then. So I need to find a point... Jesus, this is going to be a mess. I need to build the polygon, and then I need to cast a ray from some point to determine if that's inside or outside the polygon. If it's outside the polygon, I just need to find the first ray crossing, I think, and that'll work. Yeah. Yeah, we're in a mess right now. Okay, so these are points on a polygon. For... I guess I can just assume the edges. I think it might help me if I append the first thing to the end of it, just so I have the loop. My candidate point is going to be 0. Well, I mean... Okay. Oh man, this is like just annoying enough to deal with that I'm having to keep my head in the game. You know, I'm having to say, nope, we're locking in. I'm not walking away from this right now. So essentially, what I'm trying to do here is... See, this is a rather large rectangle, and if I have to check whether or not every point within that rectangle is inside this polygon, that's going to be a real mess. Is there a shorter way for me to accomplish this? Alright. 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 I'm struggling to know where I even want to start here. Because I can think of several algorithms that might work, but I worry that they're going to be too slow. I actually do want this. So how do I determine whether or not a rectangle is valid? The problem is that this is the naive way to solve this problem. There's no such thing as too slow for advent of code, but I think this might be too slow for sanity. Oh, I could memoize this. Hold on. Now I just need to solve the point and polygon problem. Because that'll memoize it. So here, I think, is where I want to... Here's where I want to do the raycast, I think. So I'm going to write a simple case first for Okay, so this just checks to see if the point is along any of the lines, in which case it would definitely be valid. And this should be a shorter test than any of the other ones. Now I need to do the ray casting. Man, I am really just struggling with unimportant details right now. I don't know that I like this part. I may remove it, but so let's go through every edge. So this is every edge. I may remove that part up there. It's not a terrible test. It's correct, but it might not actually be a time saver. So I'm going to project always to the right. So this is where I have a point that wasn't on one of the edges. I may still need this. I don't know that my logic is right otherwise. And I'll say for each of those edges, if... So I'm looking to the right, which means if this is an instance where it's a horizontal line, which would mean AX is equal to BX, then really what I want to know at this point is crossings equals 0. AX is equal to B. Oh, there is actually a clever way I can fix this. Hold on, there's like a clever way I can fix this.
Welcome to the Enrichment Center. First up, conversion gel.
Sorta. There's a way I can fix this. So there's a trick you can sometimes do when you're dealing with geometric problems on a lattice, where you can perturb each of the x and y values by some very small random value. The problem is, without knowing which side of the polygon is in and outside, I don't know which direction to perturb it. I don't know what epsilon to add in what direction, so I can't really like undo the mess in the easy way I was kind of hoping to. If I knew which direction was inside and outside, I could probably fix this easier. Okay, so if this is a horizontal line, then it crosses if and min of AY, BY.
The bean counters told me we literally could not afford to buy $7 worth of moon rocks, much less 70 million.
This is where the x values are the same, so it's a horizontal line. And AX is greater than or equal to X. And Y is between the two endpoints. Then I add one to the crossings list. The problem is when it's a horizontal line, it's not enough to just say yes or no, it's a crossing. It's a crossing if if I hit a line right on.
When life gives you lemons, don't make lemonade.
If I hit a line right on,
make life take the lemons back. Get mad! I don't want your damn lemons. What am I supposed to do with these?
then it's a crossing if then I maybe just look at the next line. Previous Y. Hello. If AX and BX are the same. Otherwise, if AY equals BY, then that's a different story. That's a horizontal line. The very last thing I want to do is I want to set previous Y to AY. Yeah, this is kind of making me wild. Yeah, this previous Y isn't going to do what I want it to do either. I have to, like, keep track of, like... This is part 2. Part 1 was, like, 30 seconds worth of code. Part 2 is beating my ass, though. I have to count the crossings.
Carolyn, please bring me more pain pills.
If it's a horizontal line, then it really just matters if we continued in the same direction. So for a horizontal, the last vertical direction is based on AY minus BY. That tells me the direction. I can do math dot signum. How do you get the sign bit? Doesn't Python have like a... Oh, okay, well I don't really care then. There's no built-in signum, but it doesn't really matter. So this is a horizontal line. If AY equals Y, nice. I wasn't aware that existed. AY equals Y. Then for the next horizontal line, I want to decide whether or not we've crossed. Oh, I can see now that this doesn't quite work. Oh no. Oh no. Oh no, another annoying issue. Oh, you know what I could do? I could perturb my Y value very slightly to fix this. Yeah. Wait, no, that's actually really easy then. Wait, I'm making my life very difficult. I don't care about horizontal lines at all. And I want to search not for y, but y plus 0.001. Now I'll never cross a horizontal line, ever. And that's good. I do need this test still. I'm gonna leave it. I want to try this on a smaller input sample. Okay, it's clearly doing the check. I think I'm on the right track here, but I'm missing something. 11,125. That works? Shouldn't that be coming up with it not being valid? Claims that's valid, but it shouldn't be. Oh wait, is it because the range is backward? Now I get 24, which is the correct answer. Okay, does it work on the big file? Not loving that. No, it is not. There's about 500 lines in here. $250,000 rectangles it's trying of various sizes. That's pretty large. You could probably immediately disqualify any rectangle that... Yeah, if there's a carve-out in the rectangle, it would necessarily have to carve out part of the border. So it might be safe to just check the border. Oh, I'm sorry. Did I say just the corners? I was talking about the edges of the polygon. They're collinear. They're collinear on the lattice. So this should be faster, but it's still not going to be great. Where am I still printing out? There we go. Alright, no idea how long this is going to take. Wouldn't it be enough to just do line-line intersection tests rather than checking each one individually being valid? While this is running, I will rewrite my code to consider that as well. Because I think that's all I want, is I want line-line intersection tests. So two lines would intersect if it's a lot of points, man. This cannot be the best way to write this. This is a really annoying problem. They made a real stinker here. So if these are both... I wrote my coordinates backwards, but it shouldn't change anything. If they're both horizontal lines, do I even care about intersection at that point? That probably isn't happening in our data set. Then I have to do the whole min-max thing. Hello. The other way around. That might work. Yeah, this one's messing me up a little bit. Yeah, the idea is perfectly clear. That's not the issue. I've gone through several approaches. One of them was checking to see whether or not all of the points within a given rectangle chosen were inside the polygon using a raycasting method. That was obviously too slow, but I kind of started there. Then the current one that's running, but it's going to take a while because it's also a bad solution, is checking all of the points on the perimeter of every rectangle, because if there's going to be a cutout, if there's going to be any piece of it missing, the perimeter is also going to have a piece missing. So I reduce the search space that way. And now I'm just trying to do basic line-line intersection, because if there's a cutout anywhere, it's going to be involved with an intersection between any edge and my line. Though this has some flaws right now, it occurs to me. God, the more I work on this code, if you've solved it, then I don't really want to know your solution. But thank you. The problem I'm going to run into is that obviously this line's going to intersect with... I think I think I can fix this by strictly checking inequality. Cool. I do not want to know that trick, but I do appreciate you asking. Thank you so much. Why would that flip back and forth? Oh, okay, hold on. I do see why that would flip back and forth. These have equal x values. I wanted to swap them so I could get equal x values. God, I really want that to be the right answer so bad. Does this give the right answer for the small set? Or did I mess that up too? Oh, that does not give the right answer for the small set. Oh, that's an interesting edge case I hadn't considered. I think I need these equalities. But I think I'm gonna get 0 here. Yeah. Because it throws out one of the lines because of the adjoining line of the rectangle. The problem is that when we're dealing with the 2 lines at the very corner, I don't want it to throw those 2 out. Well, 10,000 by 10,000 is pretty big. Or sorry, 100,000 by 100,000. Big. If I can get my line intersection method working, I think it works. I have an edge case that I'm struggling with at the moment. Still 0, huh? What if I have this backwards? Don't think this is going to be right for a different reason. Never mind, it was correct. Yeah, that makes sense. Making the rectangle smaller loses those errant intersections. This code is, so cursed. There's like an instinctual part of me that wants to go back and refactor this code. And I have to fight that urge, because that's not what we're here for. But like, not super proud of this solution, but it works. Okay. Good enough, I suppose. I'm gonna switch over to... I guess I'll play more Pikmin 2. I guess that's the plan. So...